Okay, now let's get started. Okay, so again, welcome everyone again. This is the formal start of our course. Again, the start of this course will be a bit boring, it's more theoretical, but slowly it will keep on getting interesting. But believe me, you cannot understand blockchain until unless you don't understand some of the basic concepts which I'm going to explain or which we are going to talk today. So, like any course, whether we study in engineering or in computer science or anywhere, there's always some theory to go with it. And blockchain is such a technology that there's more of theory, less of coding. But it's very important for you to understand this theoretical part so that you can go and do the theory or you can do the practical. So don't feel bored, don't sleep. Okay. If you do not understand, again, ping it on the chat box or just ask question here so that we can talk, we can discuss. All right. So our first session is understanding basic concepts used in blockchain system. So what we are going to talk of is about various small concepts. We are not going into details of any of the concept, but we will talk at a very high level that okay, what each of these word mean, and and you will see down the line that if you understand these small concept properly, you will be able to define what blockchain is. Generally, when I was there in AKG, when I was trying to explain, I tried to explain what blockchain is, but no one can understand. There's no specific definition for a blockchain that okay, this blockchain is. You need to understand these small basic concepts, and when you combine all these concepts together, it will form a blockchain. Okay, so we will go through number of concepts, but again, we are not going into detail that okay, we are not going to do a deep dive of each and every concept, but we will touch those concepts on a high level. Fair enough. So today we are going, hopefully we can cover all these functions, all these topics, but if we cannot, then for sure we will move it to the next session. Okay, but topics which we would like to cover today is hash function and data structure, private and public key, digital signatures, cryptocurrency, double spend problem, and Merkle tree. And again, as my promise, this is the only session where you will not hear the word blockchain. From next session, we will be strictly talking about blockchain, but believe me, until unless you don't understand these topics, it's impossible for you to understand blockchain. Okay. And again, as I said, that we are not going to do deep dive into each of these topics, but what we are going to do is we are going to cover it on a high level. And again, I'm saying again and again, it should be a two-way communication. Please feel free to ask. Even when I was in engineering college, I never asked question in the class, neither I used to pay attention. But this is not a class. This is just a I'm not a teacher. I know I'm a very bad communicator. I am not a very good teacher. But what I'm trying to say is that I do not know how much I'll be able to explain to you. But feel free to ask question because that way I will be able to answer you, and that way you will be able to understand more. All right. So let's get started. The very first topic is hash function and data structure. And I will keep asking you guys that okay, how much you have understand. So please keep on saying yes, no, or whatever is the relevant answer at whenever I ask those things. So hash function and data structure. As you guys mentioned, some more. I think there's a mixed combination of CS branch people and non-CS IT branch people. So therefore I'll go into more details so you understand what hash function, data structure, and all these topics are, because generally as a computer science student you go through these topics as a subject in your semesters, but non-CSIT will not understand better, but it's good to know all these information so that you can understand blockchain. Again, if you are from non-CSIT, don't think that okay, blockchain is not for you. Blockchain has nothing to do with whatever we read in specifically in CSIT. All right, anyone can read and understand blockchain. There is nothing specific in order to understand or in order to do programming which only a CSIT student will only know. All right. So definition, right? What hash function is? As you can see in front of you, hash function is nothing. Take it just as a black box. Okay. It it is a black box in which you can put string of any size. All right. And always you will get an output of fixed size. What does that mean is, forget about what hash function is, how the hash function is written. You need not to worry about it. Whenever going forward you hear this concept hash function, just understand it this way, that there is some function where you can put any string, you can take any document, you can take your book, you can take any blog, you put anything. Okay, you pass it into a hash function, you pass some random value to the hash function, and don't even worry about this random value, just worry about string input of any size. So you put anything into the hash function, and what you will get is you will get an output of fixed size. And in blockchain system, this output is generally 256 bytes. Okay, so again, what a hash function is, hash function, how this function is designed, we need not to know, but always you can input a string of any size and always you will get an output of fixed size. Okay, so any questions so far, like on hash function, although we have not covered, but still I'll keep on asking because I want you guys to understand exactly what I'm talking about. So hash function, any question, then please go ahead and ask. But only this you need to know. If you want to know more detail about a hash function, then go and do some Google and you will see how these hash functions are written. But the biggest property of hash function is that you enter any string of any size and always you will get an output of fixed size. There are some more properties of hash function. One of them is collision free, another one is one directional. And let me tell you what each of this functionality means. When I said here, string input of any size and output of fixed size. So let me quickly draw something. What we are saying here is, okay, here is this set, right? Suppose this is a superset, this is a big set, and in this, they can be all the or I should say, yeah, there's all the permutation combination of all type of strings which can exist in the world. So there's an alphabet A to Z, numeric 0 to 9, and so many symbols are there. Suppose all the permutation combination lies in this box. And now what I'm saying is that if you pass into this hash function, you will always get an output of fixed size. What does that mean is that when you are passing it, so suppose think of all the permutation combination which is here, you are always getting something which is in this set. And since output is, as I said, like generally that output is 256 bytes only. So think of this way, when input can be of any size, anything, it can be anything. But we are compressing it into 256 bytes. So just think for a second, how is that possible, right? How can we say that, entire world, entire universe, we can bring into this small box? In a more simplistic way, what I'm saying there is that if suppose I put a into this hash function, I'm getting 1 2 3. Suppose, let me make this font bigger. Okay, so I'm saying as a string input of any size, I'm entering a, I'm getting 1 2 3. Suppose when I enter b, I get 3 4 5. When I enter c, I get 7 8 9. Right, now when I enter abc, maybe I get 6 5 4. Okay, so in our example, now I'm saying that output of fixed size, the fixed size is always 3. So now you can see this permutation combination can grow, it can be anything, but always I'm compressing into 3. So theoretically, you might find one more alphabet. For example, for example, I'm saying suppose you might find some alphabet which again will correspond to suppose ABC, that is 654. Theoretically, that is possible, right?
Yeah.
So here what I'm saying is that there might be some collision possible. So one of the property I said that it should be collision free. So if you don't define this hash function properly, then what will happen? These collision will start happening in more number of time. Okay. So again, I'm repeating myself. I'm saying that okay, ABC correspond to 654. There might be some other combination of alphabet, or there might be some other combination whose hash will be equivalent to ABC. Theoretically, it is possible, but practically it is not, because that's how this hash function is designed. Now, how this magical stuff is possible, for that you will have to read whole lot of white papers and written by a whole lot of professors, because especially mathematical professors who have researched on this for years and years and has come out with this hash function, so that this hash function, we can say that practically it is collision free. And by collision I mean two such strings whose output, whose hash value are same. Okay, so by collision means that you are able to find two strings whose hash is same. Again, theoretically it is possible, but practically the chances of this collision happening is extremely less. And in, I think in humanity, like since like whatever calculation we have done, we have never find any such collision. Because if we find any such collision, then all the cryptography and all the concept of private public key, everything will fail. Okay, and that's the beauty of this hash function, that the way that you enter anything of any size, you will always get output of fixed size. Collision, that is two strings creating same hash value, is possible theoretically, but practically it is not possible. And that's what I mean by collision free. Okay, so everyone there, Animesh, Devanshu, Jatin, Pankuri, Ritika, does that make sense or no?
हाँ
Yes,
मतलब
sir, that's
मतलब
fine.
यहाँ पे देख लेना क्या क्या यूज हो रहा है ठीक है.
Okay. If not, then yeah, feel free to ask. Otherwise, should I move ahead, or it's good? Like you understand that what I mean by collision free.
Yes, sir, move ahead.
Okay, thanks. Yeah. So guys,
Just write an Android
yeah, yeah, go ahead.
right now.
Okay. Yeah, guys, yeah, keep on saying me, yeah, right, that okay, you got or you did not understand, so that way, accordingly, I will pace up myself that should I move fast or should I move slow. So I'm assuming everyone understand this part, that what I mean by collision free. Okay. So next property of hash function is that it should be one directional. And what I mean by one directional is, let me clean it up. If you are entering some input value and you are getting some output value, okay? Once you get this output, there should not be a way to go back. So what I'm again saying is, suppose, one second. Oh, I'm not a good word user. So yeah, what I'm saying is, suppose you enter A and you got 1, 2, 3, 4, 5, 6. Okay. So suppose I hide this A. Suppose this A is hidden. Okay, I do not know what was the input value. If I'm given just this, there should no way that I can figure it out what this input value was. Okay. So that's what I mean by one directional, that you can go from this side to this side, but you cannot go back. Okay. So many people call this thing as hiding. Also hiding of input string, that you can hide an input string using this hash function. Okay, and only way to figure out this this should be that you know what the input value is, you know this random value, you combine these two, put into hash function, and you will get this one. So again, it should be one directional. Okay, and one more property which I probably I forgot to mention was it should be puzzle right and puzzle friendly. I'm not sure this is the right word or not, but what I mean by puzzle friendly is that now suppose you take A and now I'm combining with a random value, I'm getting output 1 2 3 4 5 6. Okay, puzzle friendly is that suppose if I give you this value 1 2 3 4 5 6, okay, I give you this input. Okay, now I say that figure out this R so that you when you combine with A you get this 1 2 3 4 5 6. So that's a puzzle for you, right? Then now you will keep trying different values such that when you combine with A you get this particular stuff. And I will tell you why this puzzle is why I'm talking about this puzzle friendliness at this point of time. Just remember these properties, that hash function should be collision free, one directional, puzzle friendly. Because if you do not understand this thing, I won't be able to explain you what blockchain is, what mining is, or anything to do with blockchain. You need to make sure that you understand these three functionalities of hash functions very well.
Sir, can you repeat puzzle friendly again?
Yeah, sure. By puzzle friendly, okay. If I break this diagram into a mathematical function, so the way it will look is that you have this input A, you combine with R, so this is a function, so I should put it in bracket, okay. So I'm saying hash, there is a function HAR, where A is nothing but the input value, R is some random value, and when this function is executed, you get 1 2 3 4 5 6. Okay, now I'm saying by puzzle friendly means that if I give you A and I give you 1 2 3 4 5 6, okay, then they should be so, and I ask you that figure out this R, right? So there can be some way, okay, by which it can be hit and trial method, or it can be some mathematical function, whatever. Different people will come out with some different logic, so that you put some value here R, which when gets combined with A, you will get 1 2 3 4 5 6. By puzzle I mean that you will see in blockchain system
Okay.
that you will be given this input, you will be given this output, and you will be asked to create this R. And this particular feature is used in the
Okay.
mining concept. Does that make sense? Jatan, that's okay or no?
Yes, sir.
Okay.
Yes, sir. Okay. Fine.
Okay, thanks. Anyone else? Any question or any of these property, collision free, one directional, or puzzle friendly? There are more function
Sir,
properties of hash function, but yeah, what is relevant to blockchain are only these three. Yeah, sorry, Animesh, you were saying something.
sir, if it is collision free, that means it is mathematically a one-to-one function.
It's mathematically
And
one-to-one function. Practically, yes.
if it is one-to-one, then it must be invertible as well.
It must be invertible. Yeah.
That means from
So,
output we can reach to the input also.
so you are saying that if you're given this, then you should be able to find this.
Yes, yes, sir, exactly.
Yeah, that's right. It's just that what I'm saying is not it should not be easy enough. So practically it should not be possible. Theoretically, yes, it will be possible.
Okay, okay. So
So what I'm
it is
saying,
possible, but very tough it is,
no, okay,
kind of.
two things. Suppose if I give you only this, okay, and neither you have this, neither you don't know this random value, and neither you know don't and you do not know this A and R, you do not know.
ये सब
That
लोग
is,
बात ही करते हैं.
then it's not possible to get this thing back.
Yeah, yeah, definitely. But if I have many of the this values, the output values
Uh-huh.
and corresponding input values,
Mhm.
then is there a way that I can figure out the hash function as such?
Actually, Animesh, it computationally it will be so tough that with present computation power, it will be very difficult to find out. Correct me,
Okay.
Neeraj, on this.
That's right. So again, there are two things, right? So you asked me two
See,
questions. One, yeah, Ajay, go ahead.
yeah, actually, see, we are not talking about what is the fixed size here. So the fixed size, I am just going bit ahead since the question has been asked. The output fixed size is here is 256 bytes. So that size make it so complex to find out. You are right. If we try to find it out mathematically, it is theoretically it is possible, but with current computation power and everything and what the set of values you need, it is very difficult. That's all.
That's right.
Okay, that I can get. If it's a 256 byte long hash output,
Because
then
it is SHA 256 bit encryption that over the world it is followed. SHA
okay.
256.
Yeah, SHA 256. Okay, thank you, sir.
Okay, no problem. Good. Right. So coming back, that's yeah. Again, I'm just summarizing everything. That yeah, theoretically things are possible, but practically, so far, no one was able to break whatever whatever this collision thing is like. No one is able to figure out any collision because the day this collision is found, lots of cryptography, lots of the script algorithm will fail. Okay, and again, as Ajay had said, that computational power is not that big enough that we can figure it, we can break. Or in short, what I'm saying that you will that the computation power is not big enough that you are able to find a collision. Okay. And on the same note, if any one of you are reading quantum computing, then it is also said that once quantum computers comes in, then all the banks, security, everything will break. And that's the reason, because if you have a quantum computer, the processing power will increase so much that by just hit and trial, very quickly you'll be able to figure out this random value. So suppose you know this input value and you know this output, then maybe just by hit and trial you will be able to figure out this random value. And if you know this random, then you can do anything. Okay, so that's a very quick thing about quantum computing, that why it is said that okay, quantum computing has the potential of breaking all the cryptographic methodologies developed so far. But if the quantum computers will come in, then algorithm will upgrade, and accordingly we will make the system secure. Okay, so I believe we are all good with this property of hash function. Okay, let's move ahead. So let's talk a little bit now. So I'm assuming that everyone now understands this hash function. And now let's talk a little bit about data structure. That how in blockchain data structures begin.
Ajay,
Yes, Siddharth, go ahead.
Neeraj, one of the property was unidirectional or one direction. How does it help? Means in blockchain or means if you feel like if it is relevant enough right now to answer,
Yeah,
you
yeah.
can answer it.
What I can tell you is that when I say unidirectional, how it is helpful is that once you get a hash of something, you will be able to
Mhm.
share this hash with everyone, okay, without telling what
Okay.
the exact data, what the real data was. So this was the real data. A was the real data. Now
So security
yeah,
will feature in, right?
yeah, it
Because
is
of
the
it.
data security. And very soon we
Okay.
will talk about today's cell. We will talk about digital signature. I'm pretty sure that everyone understands the usefulness of digital signature, and digital signature is based on this concept only.
Okay. Fair enough.
Okay,
Thanks.
thanks. Okay, then let me move to the next topic in this section is data structure. How data is stored in blockchain, since the name itself is block and chain, right? So data is stored in blocks. And again, if you are from CSIT branch, then you will see that what blocks are blockchain is nothing but a linked list, right? Not exactly it's the linked list, but it follows the structure of linked list. So the way data is stored is, suppose this is the very first block what you see in front of screen, which contains some transaction data. Okay, What you do is you take the transaction data, you put into some block, and then you create a hash pointer of this block. So again, how you store the data? You take the data, transaction data, whatever data you have, you put into two sub block, and what block is, just take it like in any database or in Excel sheet there is one block, right, or one field of data. Assume that one field of data as one block. You have entered the data there, and then what you will do is you will create the hash of this data. Okay, and what hashes we just talked about. So you took the data, you put into some field or in some database in one field, you created a hash of it, you took the address of this field, okay, and then you stored it here. And this here h is hash pointer. And hash pointer consists of two things. One, hash of data, okay, that's one, and pointer to the data or pointer to the field. Again, hash pointer consists of hash of data and what hash is, which we just talked about, and pointer to the data. And what pointer is? Pointer is nothing as just the address. Again, CSIT will understand, but for everyone else, pointer is nothing but address of this block. Okay. So again, how data is structured in a blockchain, or how we want to structure data, that there is any field in a database or in Excel sheet, just enter or put all the data there inside that block, create a hash of it, take the pointer of this block or the address of this block and store it somewhere with yourself, somewhere at the secure position. Okay, and that's how you get the hash pointer, and that's it. If you can do this thing, and if we keep on doing whatever I just said again and again, it will form a chain of block, and that's what you will see here. In the next block, what is happening is, now you will see what we did. We took this block, right? This was, and again, this first block is called the genesis block. If you guys want to take a note, that's a generic term. The first block is always called genesis block. And the beauty of the genesis block is that as long as you have this header and the genesis block, you can create the entire chain of data. Or I should say, as long as you have this hash pointer and this first block, you can verify the entire set of blockchain. So first block, that is genesis block, and this first address, this hash pointer, is very important in any blockchain system. Going to the next one. Now you will see we are following the same whatever I described right here. We are following the same thing again and again. So what we did, this was the hash pointer, this is pointing to this, and then we created a new block, we created the hash of new block. Okay, we took the pointer of this and we stored it in the previous block. And then what we can do, we will again you keep on doing the same thing. You create another block, right, and just you create another block, create a hash of it, get the pointer of this block and store it here. And what you will do, you keep on doing this thing again and again, and eventually, and this is what a blockchain system is. And why do we need to arrange this data this way? Because of immutability. Now what immutability means is, you want to store a data in such a way that no one can come and change the data easily. Right, and everyone can go on mute.
और पूछते हैं रिप्लाई कैसे करते हैं वो लोग कहीं काम किया
I'm not sure from where this voice is coming, but guys, can we go on mute, please?
everybody else please mute
Yeah, we need
yourself.
Gaurav, is it coming from your side or?
Yeah, I think only you and me are on
Yeah, that's what I
mic.
can say. But from my side, like it's all there's no noise here. Strange. Anyway, then
So can you please mute yourself? Let's check it out. Can you please mute yourself? Yes, sir. Please mute yourself for one second. Not sure. I'm not sure from where this voice is coming.
yeah, maybe just ping on the AKGC BRC that please mute everyone if someone is by mistake has put it on and has gone outside. Anyway, let me then keep on continuing. Uh, Sorry for this disturbance. So coming back to the point, the way data is stored here is that okay, you store the transaction data, you create a hash to get the pointer of this particular block, and you store in the previous block, and this chain keep on going and going. The benefit is you will see, suppose there is a hacker or there is someone who wants to change the data of this particular block. Okay, suppose you want to change the data of this particular block. For example, instead of transaction data, you said that you want to make it transaction data one. Then you will not only have to change this block. Okay, I should say that if you change this block, then you will then you will see that even the hash of this block will change. The hash of this was stored here in the previous block. So if you change the data here, that means this value will also change. So now the hacker will not only have to change this particular block, but he will also will have to change this block too. And now if we talk about this, let's repeat the story from third block. So if you change the data here, hash of this will change. That means this block will change. And if this block, and that means hash will become hash one or hash two. And if this block will change, then this block will also change. And suppose this chain is like thousand and thousand blocks long, then you will appreciate this that okay, if you have to change one block, then you will have to change the entire chain behind, right? Again, Animate, Show, Jatin, Sankari, Kritika, any question? Does this make sense that why this data has been structured in this particular way, and what's the benefit we are getting? Guys, I need to listen from you, man. Like, are you guys following Animate?
Sir,
Mm-hmm. Yeah, go ahead.
if we change the data in the Genesis block itself,
Mm-hmm.
then I think it would be easier to do that because there is no other block
Yeah, but in
which it
Genesis,
follows.
yeah, so that's why if you make sure your Genesis block is secured, then everything is secured. And that's what you do in blockchain system. You make this Genesis block public, that everyone knows this Genesis block. So no one will be able to change it because this is a public information.
Okay.
I'm saying in a blockchain system, generally, this Genesis block is always made public so that everyone knows it. So you cannot steal a thing which is already known to everyone. You can only steal a thing which is hidden. So if this is public, even rest of all this is hidden. As long as you are getting this Genesis block at the end of the blockchain, That means all your data is all right. None of the data has been tampered.
Okay, sir, got it. Thank you.
Okay. Anyone else? Any question? Yeah. Because you can see this way, we are really building a system which is completely tamper proof.
हाँ नहीं चल रही ठीक है
This is really not good. I'm not sure from where this is coming. Maybe I don't know. We should drop all of us. We should drop and we should join back again. Gaurav, what do you say? Much better. Okay, good. So I'm not sure from where that voice was coming, but it has stopped.
Is a protocol actually we should mute ourselves if we are not?
So sorry, so that your voice was a bit low.
No, no. So I'm saying to everyone, as a protocol, what we'll follow is if we are not speaking, we'll mute ourselves, right?
Yeah, that's right. I think it's coming from Divyanshu. Divyanshu, are you there?
Yes, I have unmuted it, but it's not muting.
Because a few seconds ago you did something and then everything stopped. Is that noise from your side or no?
No, sir.
Yeah, see now it has stopped. Okay, let's so Divyanshu, if it's coming from your side, I'm not sure what's the problem, but yeah, keep it like that only. Okay, so let's carry on. So again, one final ask that